Okay, today we're going to go deep inside the engine room of our digital world, the data center. We're going to look at something that most of us never ever see, but that every single one of us relies on. We're about to uncover a hidden but absolutely critical evolution that's happening right now.
And to kick things off, let me just ask you a question. When you think about this massive, incredible boom in artificial intelligence, what do you think its biggest cost really is? Is it the genius engineers writing the code? Is it the super expensive silicon chips?
Well, the answer might actually surprise you. It's not the software. It's not even the hardware, at least not in the way you might think. The single biggest operational cost, the one thing that AI just can't get enough of, is power. Pure, simple electricity. And that power gets consumed in these absolutely massive, sprawling data centers just like this one. Every single time you do a search, stream a movie, or use an AI, it's processed in rooms filled with thousands of these server racks. And this whole infrastructure, the thing that powers our digital lives, is getting hungrier and hungrier every single day.
So here's how we're going to break it all down. First, we'll look at this soaring power problem. Then we'll see how a simple power strip basically evolved into a brain. We'll check out the new intelligence that's living inside the rack, see how that data changes the entire data center, and then finally look at what this all means for a smarter and greener future.
Right. So the crucial point here is that this isn't just, a simple increase in the electric bill. We are talking about a fundamental shift in demand that is pushing our existing infrastructure right to its absolute limits. And this really shows you the scale of the change. Not that long ago, a typical server rack might pull about 5 to 10 kilowatts of power. But now, with the crazy demands of AI and high-performance computing, we are seeing a massive leap. We're talking 30, 50, even over 80 kilowatts per rack. That's a mind-blowing density of energy in a really small space. So let's just sum up the problem, right? AI is driving these extreme power densities. Energy is now the number one cost. And in big data centers where companies rent space, the rack itself has become the billing unit based on how much power it sucks down. And because of all of this, operators absolutely have to have real-time, super granular insight into what's happening with power and temperature. Guessing just isn't an option anymore. So how do you get that real-time insight? Well, the answer lies in the evolution of a piece of hardware you've probably never even thought about, the Power Distribution Unit, or PDU. I love this visual. On the left, you've got the ancestor, a basic, dumb power strip. And on the right, you have its highly evolved descendant. The PDU has gone through this incredible technological leap, from just handing out power to actively managing it with its own onboard intelligence. So let's just be crystal clear on what we're talking about. An intelligent PDU is a networked device. It's basically a computer in its own right that lives inside the server rack, and its entire job is to collect and report real-time data on power, temperature, and load for every single thing that's plugged into it. And this leads to a pretty cool idea. We're now building an infrastructure for the infrastructure. Think of it like a nervous system of sensors and data points that's constantly monitoring the health of the data center's most vital systems. And here is how it all hooks together. This diagram shows the new architecture for managing all these devices at a massive scale. You've got hundreds, maybe thousands of individual intelligent PDUs in the racks at the bottom, and they're all feeding data up into a centralized management system. Sitting at the very top, you have the DCIM software. That stands for Data Center Infrastructure Management. And this is the brain of the whole operation. It takes all of that raw data from thousands of sensors and turns it into useful charts, alerts, and insights that you can actually act on. It helps operators see trends, plan for the future, and even automate reports on energy efficiency. So what do you actually do with all this data? This is where the real value comes in. It's all about transforming how you run the place, and most importantly, preventing catastrophic failures. Because this, an unexpected outage, is what keeps everyone up at night. For a major cloud company or a bank, downtime can cost millions of dollars a minute. So being proactive, using this real-time power data, is the absolute best defense you have. And this data reveals a ton about the health of the data center. It can identify what are called zombie servers. These are machines that are plugged in and drawing power, but doing zero useful work. That can be like a 30% phantom energy tax. It helps operators balance the electrical loads to avoid tripping breakers, preventing one little mistake from taking down a whole AI cluster.
You're getting granular data like voltage, amps, power factor for every outlet, which is critical for planning ahead, improving your overall efficiency, and getting the hard data you need for those all-important sustainability reports.
And this is the result. All that complexity gets distilled into a clean dashboard. The operator gets what they call a single pane of glass, one unified view where they can see the power, the current, the temperature of every single rack in the entire building all in real time. It's all about moving from being reactive and putting out fires to being predictive and preventing them from ever starting.
So, as we wrap up, it's pretty obvious this isn't just about a better power strip. This is about building the fundamental monitoring layer that is required for the entire next generation of computing.
This quote just says it all. The next-gen PDU isn't just a utility anymore. It has become a core piece of digital infrastructure. It is, for all intents and purposes, a dedicated sensor network that lives inside every single rack, reporting back on the health of the most critical resource of all, energy.